Video starts, I would just like to mention that I do have a website. You can access it by clicking on the link in the description below. It's just ivanhung1.webnode.co.uk. I'll put it up on screen as well, but it's just a quick message to tell you guys that you can purchase my full videos in the full videos tab. Hello everybody, welcome back to my channel. Today we're going to be going through two examples for quotient rule. So if you don't know, quotient rule is one of the rules that you use in order to differentiate a function. So as you can see on the top here in pink, we have vu prime minus uv prime all over v squared. Now if you don't know or haven't learned the quotient rule, this is the general rule. It doesn't change for quotient rule. It's like the product rule, where that one doesn't change, which is just that basically, right? That's the product rule. Same with quotient rule, same thing. This formula is the general formula, it doesn't change, and the variables used here are just given letters. They could be anything, they could be A or B if you'd like, but these are generally how they're written, so that's why I'm going to be using them in this video. So with this rule, I consider it as the hardest rule out of like the chain rule, product, and quotient rule. The quotient rule is probably the hardest, just because you need to remember the order of these two bits, right? Because if you think about it, 3 here, just ignore the rule for the time being, but if you think about 3 minus 9, right? And 9 minus 3, this equals minus 6, and this equals positive 6. Now, for subtracting, this is very important. The way that you write the order of the value if you want a specific number. But if it was adding 3 plus 9 or 9 plus 3 would both give you 12, right? Which is why with the quotient rule, we come back up here, why the quotient rule, it has to be vu prime first. It can't be uv prime, it has to be vu prime, subtract uv prime, right? So I've got that out of the way, I'll just make that more clear. So just to like break it down, this can also be written as v multiplied by du dx, which is the same as u prime, because we're going to assume that the variables we're trying to differentiate is x right now, right? Depends on the context, but it's usually x. Then subtract u multiplied by dv dx, right? All over v squared. That's basically what it's saying. So it's saying get this variable, whatever it may be in the question, multiply it by the other bit with respect to x, and then same thing over here, and then all over v squared. So v and u, once again, are just random functions. Could be anything, and in these two scenarios that we have in the bottom here, we will see the u and v's. So with that out of the way, let's just get started. I know that was a bit of a ramble, but I just wanted to make it clear, otherwise people get confused and whatnot. So yeah. Okay, so we're going to be dealing with this question first. So we know we're going to be using quotient rule fairly obviously here, because we have a numerator and a denominator. If we have a numerator and denominator, we are most likely using quotient rule. So to start, let's list our u and v. So we've got u equals, we'll just use the numerator as u, right? So it'll be 15x squared plus 7x. And then we have v, which is 3x squared, our denominator. Now we want to differentiate both of these so we can just plug in everything that we found back into the general formula, right? So we'll differentiate the u bit first with respect to x. So it'll be 30x plus 7, and differentiating v, be just 6x. Now we have all 4 of these bits, we can plug it into this general formula here. So I have v, which is 3x squared, multiplied by u prime, which is 30x plus 7. You can just put all those in brackets, just to be clear. And then we have subtract uv prime. So u is 15x squared plus 7x, then multiplied by 6x. So we'll put these again in brackets just to be clear, and then all of this over v squared. So it'll be 3x squared squared, because it's v squared, and our v is 3x squared, which is why it's 3x squared in brackets squared. A little bit confusing, but then we can simplify. So our dy by dx equals, so this bit, the bracket, would be 90x cubed plus 21x squared subtracted by, it's my calculator, 15 times 6x, so it'd be 90x cubed plus 42x squared, if I'm correct. Should be correct. And then we have all over, so 3x squared, all squared, is just 9x to the power of 4. Okay, so now we have this part, we can further simplify and say dy by dx equals, so these two will cancel out, right? Because 90x cubed subtract 90x cubed is 0. So we just cancel these out here. And we're left with 21x squared minus 42x squared, which is simply negative 21x squared all over 9x to the 4. Now, if the question doesn't ask you to simplify, then you can just leave your answer as this. But if it says like it wants it in simplest form, then find like obviously, you know, your common denominator and whatever. So dy by dx equals minus 7 over 3, because we're dividing 3 by on both parts, because like 21 divided by 3 is 7, and 9 divided by 3 is 3. So have these, oh, I forgot the x squareds, whoops, x squared over 3x to the 4. Now we can cancel out the x's and stuff, however, again, if the question doesn't want you to do that, then it's fine. So either leaving it in these forms is perfectly fine. So we've done the first bit. I'll move the second question down over here. We'll deal with it now. We'll use a different color as well. We'll use orange, because why not? Okay, so this one's slightly more tricky, a little bit more confusing compared to the other one, just because it's not as obvious that you need to use quotient rule. But I can show you that you do need to use quotient rule in just a second. So we can see here we have 7x squared multiplied by 5x to the power of a negative a third. Now, if it's a negative a third, we need to remember that we need to do the reciprocal. So, like, let's say 5x squared would just be 5x squared, right? Over 1, that's what it means. So, if we had 5x to the negative 2, this basically means that in order to make this positive, we need to do the reciprocal of the entire thing. So, this is also the same as, or identical to, 1 over 5x squared. They mean the exact same thing, right? Because in order to make the negative over here positive, you need to take the reciprocal. So knowing that and having the knowledge of that, we can say that we need the quotient rule here, because y is also equal to 7x squared over 5x to the power of 1 over 3, right? If you don't get that, it's basically because we took the reciprocal of this part of the function and then put it at the bottom, because this is also identical to 1 over 5x to the power of negative 1 over 3. So if we take the entire function, it becomes 7x squared multiplied by 1 over 5x to the power of negative a third. Sorry, that's supposed to be just a third. Right? And then that just becomes that, just in simplified terms. So hopefully that makes sense, and we'll just carry on using the quotient rule. So again, we'll list our u and our v. So u would be 7x squared, v would be 5x to the power of 1 over 3. And you've got u prime, which is 14x, and then you've got v prime, which equals 5 over 3x to the power of, just to make sure, is negative 2/3, right? So we have all our parts that we need to put into our equation, which is up here. So just a general note, that's the general rule for differentiating using the quotient rule. So therefore, we can state that dy by dx equals v, which is 5x to the power of 1 over 3, multiplied by u prime, which is 14x. I will shift this a little because I don't have enough space. There we go. And then subtracted by u, which is 7x squared, multiplied, still don't have enough space, multiplied by 5x to the power of 1 over 3, all over v squared, which is 5x to the third, all squared. So, like so, we'll just simply simplify dy by dx, just to make it look a little bit nicer. So, we have dy by dx equals, so just taking the first part, right? Yeah, I don't know why. Oh, the one moved, my bad. Okay, so dy by dx, just taking the first part, we'll do 5 times 14, which is 70, and adding the x's together because they're like terms, so you can add the powers together. We get 4 over 3, and then subtract 7 times 5, which is 35, and then x to the power, because it's x's again, so you can add the powers together, because it's a common term, the power of 7 over 3, all over, so we got 5x to the third, all squared, so that would become 25x to the power of 2/3. Okay, so that's our answer simplified. Can we simplify this any further? We could make it into 2 separate fractions, but there's no need. So our dy by dx is our answer here. Just make that a bit clearer. So, sorry if I went a slight bit quicker than usual. I've been noticing that the drop off mark is like around 7 or 8 minutes, and I didn't want my videos to be like significantly slow because people wouldn't be as engaged. So I'm going at a faster pace and assuming that you know basic knowledge very well and fluent, like such as like manipulating powers, simple chain rule and things like that. So I'm just gonna be moving a bit more quicker. Let me know down in the comments if I'm going too fast, and I'll make a slower version of this video explaining everything like bit by bit by bit. Otherwise, if you enjoyed it, like and subscribe, share the channel with your friends, and hopefully yeah, we'll have a high engagement audience. So yeah, I will see you next time.